Welcome to SIM-PAC Live. I'm your host, Geoff Matthews, and today we've got David Doral from Dovetail Electric Aviation. Welcome, David.
Thank you, Geoff. Thank you for having me today.
It's a great pleasure to have you. Now, electric aviation, you're taking on the hard tasks of decarbonising a sector that's in the hard to abate sector. What motivated you to get into electric aviation?
Yeah, indeed, it's a hard sector to abate, but I'm an aerospace engineer. I've been in the industry all my life. A couple of things. Well, first, it's hard to see something that can revolutionize an industry like aerospace. I mean, it's a one in a generation opportunity, right? So when I started to see that electrification could become that thing, I said, look, I want to be part of history. I want to, contribute to that. And I thought that the best way to do it was basically creating a company. Also, the fact that we need to decarbonize aviation is a must if we want to fight climate change. And for us in the industry, I guess that we have a responsibility of doing it. Yeah, it was like a way also to fulfill my role. To contribute to, I guess, the well-being of the whole planet from that point of view.
And did you have a background in aviation?
I'm an aerospace engineer by background. I've been working for, the first part of my professional life, I was working for the usual suspects, typical OEMs like Airbus, Boeing, Embraer, initially in very technical roles. The last 10, 15 years working in leadership positions for aerospace technology companies. So, I guess that definitely I have a background there.
And Dovetail Electric Aviation, it's a Spanish-Australian company.
So Dovetail is originally an Australian company. We registered the company, I think it was in 2021. But a couple of years ago, we also created a subsidiary in Spain in order to attract funding there and attract talent and develop also our technology over there. In the end, we're a small company, we're still a startup, but this is a global opportunity. This is a global market, and Europe, in terms of sustainability and clean aviation, is also the place to be.
Yes, and I'm a believer that collaboration is going to get us there in the end, and no one's going to do this alone. So having that reach in Europe and down under in Australia enables you to be exposed to more collaboration. And I see from your website, you've got a lot of collaborative efforts going on right the way across the technological spectrum, and also support from governments. I see you've got EU support as well as Australian government support.
Yeah, we need to get all the support that we can, right? Particularly in terms of funding. Well, we were lucky enough to get the support of the Australian federal government a couple of years ago with the CRCP grant. We also got some support from the Victorian government. And more recently, we've managed to secure European funds through a couple of programs, mostly channeled through Spanish entities, because that's where our company is based in Europe. And trying to make the most of it, because raising capital, particularly for deep tech companies like us, and particularly in aviation, is no small feat. And we need the funding and the support of all the sources that we can.
Yes. Now, for the people who don't understand what's hard about electrifying aviation or even decarbonising aviation, can you take us quickly through the problem?
Yes. Right now, aviation, the airline industry, aerospace, is probably one of the industries with the least clear decarbonization path, right? There's no credible, large airlines, they don't have a credible plan to decarbonize, right? It's different to the ground transport, where electrification has been happening now for the last 2 decades. That is typically the best solution in terms of really, make it clean and decarbonize. For aviation is more challenging because the amount of energy that you need to carry on or you need to carry with you on board is significant if you want to put that into a battery. Batteries are really heavy and only allow us to fly short distances. So that's what we're starting, right? But in terms of long distance flying, again, there's no credible plan to fully decarbonize the industry in the next, I would say, 10, 20 years.
And aviation fuel is dense as well, and that's part of the problem for you wanting to electrify, isn't it? It's the energy density that you're trying to replace.
Yeah, exactly. I mean, if you try to fly such a long flight with batteries, well, basically you wouldn't carry any passengers, and you would be flying just a small fraction of the mission of the route, because yeah, as you said, the energy density of the battery is much lower than fuel. So from a point of view, the fuel, conventional kerosene, oil-based fuel is very efficient. I mean, it packs a very high amount of energy in relatively little volume and weight. And batteries nowadays, cannot replicate that yet. So and it will take a long time for that to happen. That's why, again, electrification of aviation is so difficult.
And so you're specifically looking to try the easy ones, or the ones that you think you're technologically capable of doing, and that's short flight duration.
Exactly. Yeah. I mean, we're starting with what is feasible. That is flying short distances, 20, 25, 30 minutes. We're talking about relatively small aircraft, whether fulfilling leisure flights or leisure applications, or connecting small communities, particularly in regional parts of countries like Australia. That's what we can do. Flying 40, 50, in the future 60 minutes will even require something else like range extenders, like hybridization that we're also looking at. But that's what the technology based on batteries can do in the short term.
Yes, and take us through those technological hurdles that for you as a developer of electric aviation. What are you faced with before you can really press go on this?
Yeah, so that's coming up with an energy storage system that can pack enough energy to perform a meaningful flight. That's the biggest challenge, right? And that's the main reason why we don't see electric aircraft carrying passengers yet, right? Because you need a lot of energy, and it's hard to pack into an aircraft. Then turn that into a safe system is another big challenge, because, and interestingly, the regulations for electric vehicles suggest something like your battery system needs to be able to cope with the fire for 5 minutes, and after that, you're supposed to basically walk out, right? With an aircraft, things are a little bit more challenging because you're flying, and you cannot just simply walk away, right? You need to get the aircraft to a safe destination. That's why the regulation, the standards in aviation are way more stringent, and meeting those strict regulations and rules makes the whole thing much harder. That's one of the things that we're doing, developing technology that is safe enough to be able to pass the most strict and challenging tests.
And does that where immersion cooling come in? Is that part of it?
Yes, that's one of the innovations that we're introducing into the industry. Immersion cooling exists already as a concept for ground vehicles, but not for aircraft. And what it does is basically you keep your cells that are the ones that sometimes, when things go wrong, tend to get on fire. You keep your cells, battery cells, immersed in a fluid, in a dielectric fluid that doesn't conduct electricity, that contributes to cool down the system. Basically, provides a very efficient thermal management strategy, and at the same time, it can help to suppress fires whenever, in the unlikely but possible case that one of those cells gets on fire. This way, you manage to basically, kill that fire and keep the system intact, at least until you can, land and put everybody to safety.
And the liquids that you're using for that cooling, are they readily available, or are you developing them? What's the hurdles in that particular area?
Yes, that specific area is because we're developing technology, we're integrating different systems, we're designing some of the components of this system, the battery technology system. But in that particular aspect, we're working also with partners. I mean, in this case, there's a company called Engineering Fluids that we're developing with them, or they're developing with us a new fluid that is ideally suited for these kind of applications. But we're working together to make that happen.
So David, you've recently come back from Europe. You were at the Paris Air Show. You're working with other partners in Europe. Tell us what is happening in that Europe area for you.
Yeah. So as I said, Europe is strong in sustainability and trying to make multiple industries cleaner and more sustainable. There's a significant drive from the European Union and all the countries that belong to it to make aviation clean. Actually, there's a program called Clean Aviation that is supporting the industry, all the technologies, all the companies developing new technologies to get products to market. So that's why for us it's important to be there, because that's where we believe there's going to be a bigger push, a bigger drive to make that happen. We were presenting at the Paris Air Show some of our technologies, similar to what we did earlier in the year with the Avalon Air Show in Australia, with the Aerofriedrichshafen in Germany. And we presented our battery technology, Dovpack, also our propulsion system, Dov Power. And we've managed to attract the interest even of other electric aviation companies that see value in, rather than trying to develop a similar system in-house, using ours, right? So that was one of the areas of activity. We also use the show to sign agreements with partners and even customers, like with Swiss Aviation, that is the largest operator of Beechcraft King Airs. That is the first twin engine that will be retrofitting in the future. We're starting with the Cessna Caravan, but then we'll be moving to the King Air. So and then also other partners, technology partners, like I mentioned Engineering Fluids before, Hartzell, that is our propeller partner, and that also we met at the show. So the Paris Air Show is the largest air show in the world, so it's a place to be. And again, if we're talking about electrification, decarbonization, Europe also is a place to be.
And have you had flight yet in Europe?
We haven't flown yet, not in Europe or Australia. We're working on our first prototype, and actually at this point in time, it could happen that we may fly before in Europe than in Australia. We managed to secure a significant grant late last year, and it's a project that is allowing us to modify, to retrofit our first Cessna Caravan that should be ready for flight by the end of the year. We'll be probably flying it early in the new year. And again, because of that, because of the financial support, because of the aerospace supply chain, that strong supply chain that you can find in Europe, things are happening there.
And when you were at the Paris Air Show, did you see other people pushing sustainability in aviation? Were there other people trying to electrify and hydrogen planes and sustainable aviation fuel people there?
Yeah, I mean, of course, that's an area, a topic of a lot of interest and a lot of activity that we're seeing more and more action lately. It's true that lately sustainable aviation fuels seem to taking some speed, although they're still really far from becoming a widespread solution. And I think that as such, it may not be the silver bullet that some people are expecting to see. Hydrogen is also something that is present, but the fact that Airbus is taking is taking it easy and is slowing down the pace. It's having an impact on the industry. But yeah, there are a handful of companies that are trying to do things in, not exactly like us, but in a similar space. And actually, what we're trying to do also is whenever there is a chance to work with them, collaborate. In some cases, even offering them our own technologies. But yeah, there was a significant group of companies in the last European air shows that we've been present that are basically leading the charge in terms of making aviation clean and sustainable.
Yes, yes, and it was always going to be inevitable that you were going to see the innovation bubbling away at that grassroots small level. And now you are going to retrofit a specific type of aircraft you've got because you see that as the fastest way to commercialization. Tell us about that.
So we actually, as a company, we started with the idea of developing an aircraft from scratch, basically a brand new design. But the reality is that that is a daunting exercise. Is an endeavor that can literally take you a decade or more, and hundreds of millions of dollars is an understatement. Yeah, it could go easily over $1 billion when we're talking about a small aircraft. If it's a large aircraft, it could be way more money, right? So what we wanted to do is a positive impact on the industry as quickly as possible, and that's why we decided to take the retrofit route, where we take an existing airframe, we develop the technologies required to repower it with an electric propulsion system, and we do all the engineering modification and we bring it to market. This is much easier and faster than developing an aircraft from scratch because it's a modification of an existing aircraft. Similar in a way to what could be repowering small aircraft with, a turbine. I mean, going from a piston engine into a turbine.
Yes.
So that is a modification. This is something similar. The concept is the same.
Yes, I recently interviewed Janus Electric, who are retrofitting large prime movers and with battery swap technology and doing a great job too, by the way.
Yeah, exactly. So from a conceptual point of view, our approach is very similar. And our focus is in the development, the technology building blocks that will enable that change, that retrofit. And that is, also already a significant field, right? We're working towards bringing those technologies to market and the retrofit, the modification of existing airframes to accelerate the decarbonization of aviation, and starting with a small aircraft because that makes our life much easier and the final objective much more achievable.
Because I see early adopters in the tourism and recreational activity market. I think you've signed a heads of agreement with a skydive company.
Exactly.
And they would seem to be a prime early adopter because of the type of messaging they're wanting to push out there.
Yeah, first because it's the kind of mission that is much easier to electrify, to decarbonize. We're talking about 15-20-minute flights, and that's definitely what the battery technology can do today. But also because being a non-essential application of aviation, that's probably the kind of segment that will suffer pressures and even potential bans in the future from authorities to go electric, right? And also, we found that the skydiving community is really keen on making their sport sustainable, right? We're attracting the interest of skydiving companies in Australia, but skydiving companies also in Europe, particularly in Norway, where they're really progressive with the introduction of electrification technologies. And now we've signed a number of letters of commitment from different multiple skydiving organizations, and actually there's one skydive boss that is becoming our launch customer of our technology in Europe.
Yes, because it would be one of the most ironic things you could do is take a glacial flight. To look at the melting glaciers.
And look, definitely in that case, what we need to do is to make sure that we keep our battery cool, right? or sorry, the other way around. We need to make sure that we keep the battery warm, right? And that is actually something that people don't realize, but that is also a part of the challenge, right? That sometimes when you're operating in very low temperatures, the battery needs to be warm, not just simply cool.
Yes, yes, and I'm assuming your liquid can keep it in the right temperature range.
Yes, exactly.
And are you keeping an eye on cell technology, especially out of China?
Yes, places our cell provider comes from Taiwan, and yeah, we've been testing cells from other providers. We're looking definitely at new chemistries. The one that looks more promising is solid state cell chemistries, or semi-solid states. And yeah, we're planning to have a collaboration project with actually a company in Europe that is also developing solid state cells. But we're looking at other possibilities.
Yes,
Lithium sulfur, for instance, yeah, with an Australian company, LIS Energy here in Australia, and other options. On the one hand, we're focusing initially on the technology that is robust and mature and that's in the market, typically lithium ion NMC technologies, and those are the cells that we're using from Molicel, our Taiwanese provider. But yeah, we're looking at what is coming next,
yes,
because in the end, yeah, any improvement that you can get in energy density definitely will help us.
yes, yes. Because Dovetail Electric is a SIM-PAC Live member, and so too is LIS Energy, from Queensland, and as well as Graphene Manufacturing Group, and they are pushing the edge with their aluminium ion battery, which they're using their graphene in it. Again, all for lightweight, all for high energy density. They may come into play at some stage.
Yeah. So look, we're definitely following that closely. Again, the question is how long it will take for those technologies to be robust, mature. But
Yes,
yeah, we definitely are keeping an eye, and in some cases even collaborating with those parties. But yeah, at different time frames, right? The products that we're bringing to market now are based on, at least from a battery cell technology, on mature technology, lithium ion NMC, and that will be the first products that yeah, we'll bring to customers. But yeah, definitely looking and already working on the next generations of our battery technologies.
yes, and I note that last year you won a SIM-PAC Live Sustainability Award for breakthrough solution, but I see the Aviation Awards also recognised you for Innovation of the Year.
Yes, actually, we won the award by Australian Aviation yeah, last August, as the innovation of the year. We're also competing this year, and I think that the ceremony is next week. Yeah, and we're yeah, presenting the work that we've done, particularly with our electric propulsion system in the last 12 months. So yeah, we've been recognized and acknowledged by a number of parties. We'll be present again on the final next week, the Solid Aviation. But that's all very positive and good attraction that yeah we're generating, and yeah, it's good to see interest from different people, because definitely we need to create or we need to attract the interest also of the general public to make them aware that what we're doing is important and is needed for the progress of the industry.
Yes, and the future for you, the next steps, commercialization. Do you have funding? Are you going to raise funds? Are you ever looking to go public with that, or how are you going to navigate that journey?
Yeah, I mean, we're always working on that regard. Actually, we're working right now on the second tranche of our seed round. So we're raising $5 million US, so around $8 million Aussie, and to be honest, we're looking more outside of Australia because we believe that is easier right now, particularly when we're talking about deep tech hardware and particularly aviation, to attract the interest and the money from investors overseas. But yeah, we're working right now in that round. Hopefully, we'll be able to close it by the end of the year, with the intention of using it to progress with our flight test campaign and to progress towards the certification and the industrialization of the product.
Yes. And that flight test, have you got a timeline for that? When can we expect to see the first battery powered electric plane flying from you?
Yeah, so we're planning to do it by the end of this year, but yeah, because of number of things slowing us down, and again, the challenges, lately the last 2 years to raise capital is one of them. So that's why we had to slightly postpone our plans. But our roadmap includes having a first flight Q1, Q2 next calendar year. Right, so definitely we're planning to fly before mid-year 26, and with that we will continue with our flight test campaign. That the intention is to start generating what is called credits with the regulators, in particular EASA, because yeah, that's where we believe approvals will come first, and yeah, that link with the industrialization of the product and the commercialization of it.
And how big a hurdle is the approvals? Because I know a number of American companies have started their test flights in New Zealand, in the South Island of New Zealand, obviously perceiving our insurance risk and our perceived regulatory hurdles less in New Zealand. What's the landscape look for those hurdles? Are they the same for you in Europe and Australia?
Yeah, they're different. I would say that CASA is relatively progressive and helpful and open to these kind of developments. So I would say that doing a first demonstration flight, probably is a little bit easier in Australia than in Europe. But in the end, what you need to do is not just simply do a pilot flight or a prototype flight. What you need to do is progress towards approval and certification of the technology. That is the bigger challenge, right? Because in the end, is the difference between just having a one-off or doing a one-off demonstration flight, purely experimental, with a product that you can bring to market and commercialize. But obviously, to do that, the technology needs to be extremely safe. Aviation is renowned globally because of that, because it's probably the safest means of transport. And that is because the regulation has evolved, has grown, has matured to a very high level, high standard level, right? So that's what we need to do, and that's a big challenge, to basically demonstrate that all the different components, all the different technologies that we're developing meet the highest safety standards and are safe for the public, right? And that doesn't happen overnight. So but well, we're gonna get there, and the path that we've taken in terms of retrofitting existing aircraft relies on the design and the good work done with previous aircraft, right? So that's why we believe that we're in the position to accelerate, to streamline that process.
Yes, because it would seem that this is a product that if you built it, they would come. If you had it and it was approved for flight and you had a product available, there's a ready market waiting for it.
Yeah, and I mean we've done a lot of market research activity and work, right? And we've done we've gathered a lot of market intelligence, and we've managed to attract the interest and the commitment from a number of operators and users, right? And that's where this opportunity for skydiving, also for scenic flights, come from, because we know that those companies, they are really looking forward to seeing the technology hitting the market, because in some cases they're gonna see themselves under pressure if they don't come up with a sustainable, quiet, and cleaner technology. So the market is there. In some cases is up to us to bring it as fast as possible, but the market is there.
Yes. David, if there are any companies out there in Australia that you see as your end users that they want to get in touch, they can get in touch with you through Dovetail Electric Aviation, can't they?
Yes, of course. Look at our website or LinkedIn page. But yeah, we're really looking forward to hearing from more operators, particularly in those segments where we're bringing a solution first. We're talking about the skydiving companies. We're already in contact with the skydiving companies in Australia and working with them. But any additional operator that would like to hear more about how to turn their fleet into electric clean aircraft, please approach us. Also scenic flight companies, there are a number of them that are working with us, and even passenger transport, particularly for short to mid routes. We're starting to work on a potential hybrid version of our technology. Our propulsion system will be always 100% electric, but yeah, we're working with other partners to introduce range extenders. So what that means is that we'll be able to fly longer distances by the generation on board of electricity, potentially even with the turbine. And yeah, that will enable the connection by air of remote communities, particularly in rural Australia, the outback, and so on. So we're working particularly with air ambulance companies, but yeah, we're very keen to hear anything about the passenger transport for those regional airlines that they are trying to connect the country, right? So yeah, that's probably our next step, our next wave of technology development and activity in our roadmap, and would love to hear operators, particularly in Australia, because we know that general aviation is critical to connect and for the connectivity of the country. So we're really keen on hearing from operators in that space to approach us and start working together.
Thank you, David. Look, that's all the questions I had for you today. If anyone's got any questions for David, could you please put them into the live chat now on YouTube? And David and I will be online for the next 20 minutes or so, and we'll answer your questions. David, thank you so much for appearing on SIM-PAC Live today. Really enjoyed having you.
Thank you, Geoff. I really appreciate the opportunity, and always enjoying the chat with you.
Thank you.